Hello everybody. Now you're used to me talking about energy savings and how we're all spending too much on energy. Well, today we're doing something a little bit different. We're at a wonderful commercial building in central London. We're here with colleagues from ABB and also from all-bms, and we're talking about energy saving in HVAC applications. So Carl, tell us what's going on here.
Hi Andrew. We're here today to talk about how easy it is to save energy in HVAC systems. So typical systems may be fans and pumps, air handling units, hot water, cold water, just simple applications that are actually not really optimized today. So with all-bms, one of our system integrators that we work with, we've done quite a bit of work at this site over the past, and we've done that by installing variable speed drives on those applications, reducing energy, but not only just reducing energy, but reducing CO2 and making significant savings. Now, we all know how much electricity costs have gone up. So savings 5 years ago are very different to today. So multiplied by 3 times means a quicker return on investment and, of course, bigger financial savings.
Okay, so you've got us on the hook here now, because that's really quite an essential thing rather than a preferred thing. So that's quite interesting. Let's dig a little bit deeper into this area. So Chris, turning to you, what role do drives play in making a building like this more sustainable?
Well, we could be talking a building like this, but we actually could be talking any commercial or industrial premises where there are opportunities, numerous in many cases, where water and air are run through ducts across the whole area and the whole building for the HVAC system.
Okay, so are we talking about things like stadium? Are we talking about hospitals?
We're absolutely, it could be any public building, but certainly you mentioned hospitals, data centres is another one. But certainly any public building where people exist and cohort, no, that is exactly the type of buildings we're talking about.
Okay, so the stadium, let's say a football stadium typically, used heavily at the weekend, maybe not used as much in the week. The level of savings potential there could be really quite substantial then.
Yeah, here at this particular facility in the heart of London, we're talking tens of thousands. But in actual fact, in some other properties or buildings like Stadia you mentioned, that could be hundreds of thousands. You might think indeed, no, that a stadium might only be used 2 to 3 times a week. But there are office parties, there are gigs and bands playing at some of these things throughout the summer. So in actual fact, it might not just be, give an example, the football in the winter, through the summer months you might think it's empty. Not necessarily, it could be all year round.
Okay, so that's really quite substantial. So when we talk about the level of savings, could you give us a bit more clarification on how much is being saved in terms of percentages?
In terms of percentages, well, if you actually use a variable speed drive, then we're getting away from a traditional type system where it would be running flat out 24/7. Now, if we reduce it by just 20%, you're actually looking at 50% savings, and that's not just financial savings, we're actually reducing the carbon footprint too, so helping the government objectives to reach net zero.
That's fantastic. That's really quite a major insight on there. So let's get down to some practicalities now. Carl, can you tell me about the energy assessment? What are the environmental and financial benefits of doing this?
Yeah, sure. ABB offer an energy assessment. So in simple terms, we arrive on site, we look at various applications, generally all types of motors. That may be whether if it's on an air handling unit or it may be pump. We then look at how they're controlled. It may be that they have a conventional control, that'd be a direct online, a star delta or a soft start, or in some cases a variable speed drive. Now, if they are conventionally controlled, that really lends its hand to install variable speed drives, a real opportunity to save energy and reduce CO2. And basically what we do there is we look at the absorbed power, we take the measurements, we then compile a report, and then we feed that back to the necessary facility manager. Or if we're working with a system integrator, we work with the system integrator to give that to the facility manager or the end user, as that may be. Now, it also may be that it already has a variable speed drive on. Now, if it does, then great. If it's in good working order and it's serviced, And that also goes for the motor as well. It's really important that the motor is serviced and not just left. Now, if it does have a drive on, great. If it's a critical application, then the aging of that drive is really critical. If it's an end-of-life product, you know, we have drives out there that are 20 years old, but if it's a critical application, such as a data center or a hospital, then the last thing they want is for that variable speed drive, or in fact the motor, to fail, and then all hell breaks loose.
Understood. Yeah, I can completely see. Now, you've mentioned your integration with all-bms. So how important is it to work with people that actually deliver this end product?
Oh, it's absolutely massive. We're the manufacturer. We don't actually physically go and install drives, but we use a consultative approach for that. All-bms are really the integrators that would put a drive, but not just a drive, but integrate it with the BMS system and actually optimize the plant as well. It may be, and we quite often see it, that somebody installs a drive and it's just left to run at a reduced speed and not actually optimizing the plant. Now, all-bms can go one step further and start integrating things like CO2 sensors.
Okay, that's excellent. Thank you very much, Carl. Let's now turn to all-bms. Now, Lucy, you're the energy manager for all-bms. Could you share a bit more detail about this specific project?
Yeah, sure. We've done an upgrade over this specific site back in 2020. Now, I've just pulled from our energy report that we've done previously. Savings on a condenser pump annually saved £3,322. Now, that's just saving on one pump for 1 year. That's quite a large sum and a big figure. Energy saved was actually 12,800 kilowatts, and the payback period for that was just 9 months. The savings on that obviously was quite vast. Now, looking back, that obviously was done back in 2020 when energy rates and tariffs were quite a lot lower than they was today. So if we was looking at doing an upgrade on a project like that today, obviously it'd be even massive more savings.
I mean, that's a huge amount of money, isn't it?
Yes.
That is a huge amount of money. And that's very real, because that's profit line for companies, isn't it?
Of course, yeah. And like I touched upon, the payback period for that would have been 9 months.
Which is fantastic. Really good insight. Thank you so much, Lucy, for explaining that. I really appreciate it. So what we've learned today and what we've picked up is that there are some very substantial savings that can be made. One of the clear things that's come out of today is that we possibly are all in a position to make savings such as Lucy has detailed for us. So the obvious thing, of course, is why not start the process? It costs nothing to ask, to talk to these guys. Let's get an accurate assessment on the energy that you're consuming and see what could be done. It will be interesting to see where this goes, but for absolute certainty, we all need to save money on energy. Thanks ever so much for watching. All the contact information will be on the final screen, and we look forward to seeing you on the next video.